All right, let's dive deep today.
Sounds good.
We're going to be exploring something pretty cutting edge.
Oh.
Sparse autoencoders,
Okay.
or SAEs, as I'm sure you know,
Right.
and how they're being used to understand large language models.
LLMs.
Yeah, LLMs, exactly.
Cool.
So think of SAEs like
Okay.
a way to break down the complex activity inside an AI.
Interesting.
Kind of like we're identifying the recipe of an LLM's thoughts.
It's like we're trying to understand this complex dish.
All right.
But instead of a list of ingredients, we just have this like intricate web of interactions.
Yeah.
So these SAEs can kind of help us tease out the individual ingredients.
Yeah.
Those like fundamental building blocks.
The building blocks of what's going on inside. And what I think is really cool is that the research that we're looking at today is fresh off the press.
Nice.
From Google DeepMind.
Wow.
It's called Gemma. Open sparse autoencoders everywhere all at once on Gemma 2.
That's a mouthful.
It is. It is. But this paper described a massive project.
Okay.
And I think it could change how we understand and control LLMs.
What's really remarkable is the sheer scale of this project.
Yeah.
They trained SAEs on practically every part of the Gemma 2 LLM.
Really?
Every layer, every sub-layer.
Wow.
You name it.
Wow.
They even tackled some select parts of the massive 27B model.
Holy
We're
cow.
talking over 400 SAEs,
Okay.
30 million learned features,
Goodness.
and a staggering 20 petabytes of data.
For 20 petabytes.
That's, well, it's a lot of data.
It is.
But here's why I think this should make everyone's ears perk up. This level of analysis used to be exclusive
That's right.
to those really big AI labs.
Huge, yeah.
But because Gemma Scope is being open source,
That's a game changer.
it is.
Yeah.
It means anyone with the right knowledge can explore these tools
Uh-huh.
and potentially make their own discoveries.
Yeah, it's a total game changer for the research community.
For sure. Yeah.
This level of accessibility is huge.
Yeah.
It allows for so much more collaboration,
Right.
scrutiny, and ultimately deeper understanding of how LLMs work.
Definitely.
But before we get ahead of ourselves, let's take a step back.
Okay.
I know we've thrown around a few terms.
Right.
Can you just remind us,
Sure.
what exactly are SAEs?
So imagine you have this incredibly complex recipe
Okay.
with hundreds of steps and ingredients.
Right.
An SAE is like a tool that can condense that recipe down to just its essential elements.
Okay.
It finds the core ingredients and how they interact without losing like the essence of the dish.
So it's kind of like a super efficient recipe book.
Yeah, you got it.
Getting rid of all that fluff,
Right.
leaving us with just the bare necessities.
Exactly.
Right.
And within that recipe book analogy, we can see the two key parts of an SAE,
Okay.
the encoder and the decoder. So the encoder is like this chef who meticulously analyzes the recipe, identifying the key ingredients, the proportions.
Oh, yeah.
That creates like a compressed version.
Right.
Then the decoder is like another chef
Okay.
who takes that condensed version and reconstructs the original dish.
Okay, that makes the encoding and decoding process much clearer.
Cool.
But what about the sparse part?
Right.
Why are these called sparse autoencoders?
That's where the magic happens.
Okay.
Sparse means that the SAE is designed to use only a small number of those core ingredients at any given time.
Right.
This makes the results much easier to understand and analyze.
Right.
We're not overwhelmed by a jumble of information. We can just focus on the most important elements.
So it's like highlighting the key parts of that recipe.
Exactly.
The ones that truly define the flavor profile. Now, in the Gemma Scope project, they used a specific type of SAE.
They did.
It's called a Jump ReLU SAE.
That's right.
Why that specific type?
So they found that Jump ReLU SAEs offer better fidelity.
Okay.
Meaning they could reconstruct the original LLM activity more accurately.
Gotcha.
They also allow for flexibility in the number of features used.
Interesting.
Unlike some other types that always use like a fixed number.
So they applied these Jump ReLU SAEs to all sorts of places.
They did.
Within the Gemma 2 LLM.
That's right.
Were there any specific areas they focused on?
Absolutely.
Right.
They targeted 3 main locations within the LLM architecture.
Yeah.
And figure 1 in the paper provides a helpful visualization.
Right.
The first location is the attention head outputs.
So that's where the LLM is focusing its attention on different parts
That's right.
of the input text.
Like how your eyes scan a page.
Right.
Picking out the important words.
Makes sense.
Yeah.
What was the second location?
Next, they looked at the MLP outputs.
Okay.
MLP stands for multilayer perceptron.
Okay. Which is the workhorse of the LLM. Right. This is where information gets processed and transformed.
Gotcha.
Like a chef combining and cooking the ingredients.
So attention head outputs show us where the LLM is focusing.
Right.
And MLP outputs show us how it's processing information.
Yep.
What about the third location?
The third location is the residual stream.
Okay.
Think of it as the information superhighway within the LLM,
Okay.
where data flows between different layers.
Gotcha.
This is how different parts of the model can kind of communicate and build upon each other's work.
So they strategically place these SAEs to observe the LLM's focus, its processing, and the flow of information between its parts. That's a pretty comprehensive approach.
It is.
But I'm curious, how do we know if an SAE is doing a good job?
That's a great question.
Like, is there an SAE report card or something?
Unfortunately, there isn't one definitive way to measure SAE performance.
It's an area of active research.
Right.
Which adds to the intrigue of this whole endeavor.
Yeah.
In this paper.
Yeah.
They use two key metrics.
Okay.
Delta LM loss.
All right.
And fraction of variance unexplained, or FVU.
Okay, but break those down for me.
Sure.
What are those metrics actually measuring?
So delta LM loss tells us how much the LLM's performance drops.
Okay.
When we use the SAE's simplified representation instead of the original data.
Okay.
You think of it like substituting a few ingredients.
Yeah.
In that recipe we talked about earlier, a small change might not be noticeable.
Right.
But a big one could ruin the dish.
Totally.
Ideally, we want this drop to be as small as possible, indicating that the SAE is capturing the essence of the original information.
So the smaller the delta LM loss, the better the SAE is at retaining.
That's right.
The important information. What about FVU?
FVU, or fraction of variance unexplained, measures how much of the original activity the SAE fails to capture.
Okay.
In our recipe analogy, it's like seeing how much of the original flavor is lost after we simplify the recipe.
Makes sense.
Again, lower is better.
All right, so lower delta LM loss and lower FVU mean a more successful SAE.
Exactly.
But you mentioned this is still an evolving area of research.
It is. Yeah.
There must be a lot of unknowns when it comes to evaluating these things.
Absolutely.
Even with these metrics.
Yeah.
There's still a lot of debate and ongoing research. I see.
About how to best assess SAE performance.
Okay.
It's a field full of fascinating complexities.
I have a feeling things are about to get even more fascinating.
Yeah.
With all these SAEs strategically placed within the Gemma 2 LLMs. What did the researchers actually uncover?
Oh, there are plenty of surprises.
Okay.
Get ready for some counterintuitive results.
All right.
And some very thought-provoking questions.
I like it.
Because Gemma's scope has revealed some intriguing aspects of how these massive LLMs actually tick.
I'm all ears.
All right.
Let's dive into those findings.
Let's do it. Well, remember that residual stream?
Oh, right.
The information highway within the LLM?
Right, the one that connects all the different layers?
Gemma's scope found that even tiny errors in reconstructing the activity in the residual stream had a huge impact on the LLM's performance.
Wow.
Much bigger than similar errors in other locations.
So messing with the residual stream is like introducing a glitch into the LLM's like central nervous system.
Like a little disruption could throw everything off.
Right.
And that leads to some really interesting questions.
Such as?
What is so crucial about the information flowing through that residual stream?
Yeah, what is it doing?
Is it some kind of master control signal?
Right.
Or is it more like this delicate balance of feedback loops that keeps the whole system running smoothly?
That's fascinating.
It makes you realize how much we still don't know about how these things think.
Yeah, totally.
Were there any other findings?
Yeah. Were there any others that caught your eye?
Another surprising discovery relates to the position of words in a sentence.
Okay.
Gemma's scope revealed that SAEs are actually better at reconstructing activity for words that appear later in a sentence.
So the further along you go in a sentence,
the
clearer the signal becomes.
That's right.
Why would that be?
It seems that later words have more context
Right.
built up around them.
Yeah.
The LLM has already processed the earlier parts
Yeah.
of the sentence.
Okay.
So by the time it reaches those later words,
Yeah.
it has a richer understanding of their meaning
Okay.
and their relationship to the rest of the sentence.
It's kind of like when you're listening to a story.
Yeah.
Like the first few sentences might
Yeah.
feel
Right.
a bit disjointed.
Yeah.
But as the narrative unfolds, more details are revealed.
Yeah.
Everything starts to make more sense.
That's a great analogy.
Thanks.
It highlights how LLMs
Yeah.
don't just process words in isolation,
Okay.
but they actually build this complex understanding
Right.
as they go.
Okay.
Now, prepare yourself for this next one.
Okay.
It's a bit of a head scratcher.
Okay, hit me.
The researchers noticed something called feature splitting.
Feature splitting.
As they made their SAEs wider, giving them more features to work with, they observed that some existing features started to split into more specialized versions.
So like one feature becomes two.
Yeah.
Each with a more specific purpose.
You got it.
Okay.
It's almost as if the SAE is saying, hey, I have more space to work now.
Right.
I can break down this complex concept
Right.
into these smaller, more nuanced pieces.
That's really interesting.
It is.
But does this make the SAE more powerful and accurate?
It's a mystery that we're still trying to unravel.
Okay.
We need more research to understand the implications
Okay.
for things like using SAEs to control or debug LLMs.
Right.
But the fact that we're even seeing this phenomenon suggests there's a lot more going on under the hood than we initially thought.
For sure. It sounds like feature splitting could be a key to unlocking deeper levels of understanding about how LLMs work.
Exactly.
Were there any other revelations from Gemmascope?
One more finding that I think is relevant to our listeners is that SAEs trained on the basic LLM did a surprisingly good job at reconstructing activity in versions of that LLM that had been fine-tuned for specific tasks.
So even though those fine-tuned LLMs were specialized for certain tasks, the SAEs could still make sense of what was going on.
That's exactly right.
Okay.
This suggests there's a core set of features.
Okay.
Those fundamental building blocks of LLM thought. Right.
That are shared across different versions of the model.
So it's like different chefs.
Yeah.
Using the same basic ingredients
right.
to create vastly different dishes.
You got it.
Right.
The core elements are there.
Yeah.
Even though the final product might be completely different.
That's pretty mind-blowing.
It is.
This finding leads us to some pretty profound questions.
Such as?
Are these features truly capturing the concepts that the LLM is using?
That's the big question.
Could we one day map those features onto, like, human understandable concepts?
It'd be amazing.
It would be like having a Rosetta Stone for AI, allowing us to finally decipher the language of these complex machines.
That's the dream.
What other mysteries could Gemmascope help us solve?
A big one is whether we can use SAEs to detect or even fix harmful AI behavior, like those jailbreaks that can trick LLMs into doing things they shouldn't.
Or maybe we could use SAEs to understand
those more complex LLM processes, like chain of thought reasoning, where the AI thinks through problems step by step.
Almost like a human.
And of course, there's always the possibility that SAEs are missing something crucial. Could there be a sort of dark matter of non-linear features that are too complex for SAEs to capture?
So many questions.
So many questions.
So much potential for discovery.
I know.
It feels like we've only just scratched the surface.
We really have.
Of what SAEs can teach us about LLMs.
It's just the beginning.
That's the beauty of cutting-edge research.
It is.
There's always more to learn, more to explore, more to question.
And thanks to Gemmascope being open source, anyone can join this adventure.
So where does all of this leave us?
Well,
what are the big takeaways?
I think the most important takeaway is that SAEs are incredibly powerful tools for understanding how LLMs work.
They're giving us unprecedented insights into the inner workings of these complex AI systems, revealing patterns and structures that we never would have seen otherwise.
And those insights are already leading to new discoveries and raising even more profound questions about the nature of AI, how it learns, and how we can control and guide its development.
Exactly.
And the fact that GemmaScope is open source means that anyone can join the quest to understand and improve these powerful AI systems.
Definitely.
It's a really exciting time to be involved
It is.
in this field.
Yeah.
Before we wrap up this deep dive,
okay,
I have one final thought-provoking question for you and all of our listeners.
Okay, shoot.
If you had access to GemmaScope, what would you investigate?
Ooh.
What mysteries of the LLM would you try to unravel?
That's a great question to ponder.
Take a moment to consider that, dear listeners.
Yeah, think about it.
We'll be right back.
We'll be back.
To wrap things up.
Yeah.
And point you towards some resources where you can learn more. Welcome back, deep divers.
Back again.
I hope you had some time to think about that question.
Yeah.
What would you investigate using GemmaScope?
So many possibilities.
It really is a question that could lead you down
some
fascinating rabbit holes.
Absolutely.
And that's precisely what makes this whole field so captivating. We're really on the frontier here.
We are.
Of understanding these complex AI systems.
Absolutely, yeah.
And with tools like GemmaScope.
It's like we're just beginning to unlock their secrets.
Let's recap our journey today. We started by exploring the concept of sparse autoencoders.
SAEs.
Or SAEs. These are like powerful lenses that allow us to zoom in on the intricate workings of LLMs and identify those fundamental building blocks of AI.
The features.
The features, exactly.
Yeah.
It's like having a blueprint of the LLM.
It is.
Showing us not just the individual components, but also how they interact and contribute to the overall function.
Exactly.
And the beauty of GemmaScope is that it provides this incredible level of detail. We're not just looking at a small slice. We're examining every nook and cranny from the attention heads to the MLP outputs to that crucial information highway.
That's right.
The residual stream.
The residual stream.
And speaking of the residual stream, remember how even small errors in reconstructing activity there
I do.
had a significant impact on the LLM's performance?
Big impact.
It really underscored its importance.
It's like realizing that a seemingly minor wire in a complex machine is actually carrying vital control signals. Disrupt that wire.
And the whole system could go haywire.
It could,
That finding alone has sparked so many research avenues. Like, what exactly is flowing through there?
What is it?
How does it influence the LLM's decisions and outputs?
The big questions.
We also uncovered that unexpected relationship between a word's position in a sentence and the SAE's ability to reconstruct its activity. The further along in a sentence we go, the clearer the signal becomes.
That's right.
And it just highlights how LLMs build an understanding of meaning as they process text.
It's not just word by word. It's this dynamic process where context and relationships between words play a crucial role.
And then there was that mysterious feature splitting.
As SAEs get wider and have more features to work with, some of those features begin to divide into
more specialized versions?
A phenomenon we're still trying to fully grasp.
Trying to understand.
Is it a sign of the SAE becoming more sophisticated in its analysis? Or is it a potential pitfall?
Could be.
Leading to unnecessary complexity.
More research is needed.
But perhaps the most exciting finding was that SAEs trained on a basic LLM could transfer their knowledge to versions of that LLM that had been fine-tuned for specific tasks.
It's like they had this grasp of the LLM's core abilities, regardless of the specific application.
It suggests that there's this fundamental universality in the way LLMs represent and process information.
It's like we've discovered this hidden code, a language that transcends individual tasks and reveals something profound about the nature of AI.
But it's important to remember that we're still in the early stages of this research.
We are, There's still so much we don't know.
A lot to learn.
About SAEs and how they can be used to understand control and improve LLMs.
Exactly.
That's what makes this field so exhilarating.
I know,
There's so much room for discovery, exploration, and innovation.
And thanks to Google DeepMind, open sourcing Gemmascope,
anyone with the right knowledge and curiosity can join the adventure.
Absolutely.
If you're intrigued by what we've discussed today, and want to learn more about SAEs and Gemmascope, we've included some links in the show notes.
Check them out.
You'll find the original research paper, code repositories, even some interactive visualizations that allow you to explore Gemmascope's findings firsthand.
Awesome.
And remember that final question we posed.
The big one.
What would you investigate using Gemmascope?
Don't let that curiosity fade.
It's a really good question.
Maybe you'll be the one to uncover the next breakthrough in AI interpretability, or even stumble upon a brand new question that no one has even thought of yet.
And that's what the deep dive is all about.
That's what we do.
We're not just here to present information.
Right.
We're here to inspire, to spark curiosity, and to empower you to explore the vast, uncharted territories of knowledge.
So keep diving.
Keep questioning.
Keep pushing those boundaries.
And who knows what wonders await beneath the surface.
You never know.
Until next time, deep divers.